So okay, hello everyone, welcome to CUCET Academy. Okay, so in this video, I will go to this. I will cover. Okay, I will cover the some basic example or some basic problems of spherical charge distributions. Okay, and this lecture is very useful for B.sc physics majors who are in semester 2 and also who are preparing the IIT JAM, Jest, TIFR and also CSIR NET GATE examinations. Okay, so I think this lectures is a general video, and this is a general lectures for all kind of aspirations, right? So let's start our videos. Okay, let's start our videos and let me explain some basic problems. Okay, so okay, let's this is actually lecture number 8. Okay, so in previous lectures, lecture number 1 to lecture number 7, I've discussed some lecture number 1 to lecture number 7 I was discuss basic problems, basic theory regarding electricity and magnetisms. Okay, and also I was discuss some how to deal with the spherical coordinate system, how we deal with Cartesian coordinate systems, also in cylindrical coordinate systems, right? So in that lecture, I let me explain some problems. Okay, so if anyone in my channels is the first viewer in my channels, please subscribe and keep the hit the bell icon for further notifications in futures. Okay, and if you feel those lectures are very useful for you, and please share with friends who are in B.sc physics, B.sc physics honors, and also who are preparing IIT JAM, Jest, TIFR and also CSIR NET examinations, right? So okay, so let's start our video with some problems. So let us take a heading. We are discussing problems of spherical charge distributions. Okay, spherical charge distributions. So let us take a first problem. What is the problem? This is the question number 1. A charge distributions. Please take a note. Okay, please take a note all and each and questions. A charge distributions gives rise to an electric field E vector equals to E0 upon R square e to the power R upon A R cap, where A is a constant. Okay, A is a constant. So determine the total charge in the distributions. So please kindly try to understand what is the context of these questions. A charge distribution gives rise to an electric field. Okay, charge distributions gives rise to an electric field, and we have to we will determine the total charge in the distributions, right? So our main goal in this questions is try to find out the total charge in the distributions. Okay, so first of all you understand the what informations actually given in the question paper. Okay, so here given is the electric field. First of all you have noticed here electric field is given. Okay, so in solutions part here electric field is given, and it is not a constant electric field, it's like a coordinate dependent, position dependent electric field. This is given actually. Okay, so from this electric field we will determine from this electric field we have to determine the total charge in the distributions, right? So for that calculations or for to reach the goal, we use the basic basic physics. Basic physics means basic physics of electrostatics, that is the Gauss's law. So generally we know Gauss's law have two form actually, right? One is the integral form of Gauss's law, and there is a differential form of Gauss's law. But in that case we use the Gauss's differential form of Gauss's law. Okay, so we have two form Gauss's law. So differential form of Gauss's law. That is nothing but divergence of E vector equals to rho upon epsilon naught. E is the electric field, rho is the charge density. Okay, so from these expressions we have to calculate total charge density, and then we calculate the total charge. Okay, so let's use, but here the electric field given in spherical polar coordinate system. Okay, so for spherical polar coordinate system use that what is the gradient divergence rule. We use the divergence rules for the spherical polar coordinate systems. But you have noticed here, the given electric field have only the radial component. Okay, so others component, right, the theta and phi component are not mentioned here. So this is a very easy question. Okay, so what is the so just put here the radial component of electric field. Okay, just put here the radial component of electric field. So divergence of E0 upon R square e to the power R upon A R cap. Okay, and that is equals to rho upon epsilon naught. Okay, just solve this. Before you're going to solve this divergence, try to write in the bracket term in a kind of good manner, right? So divergence of E0 e to the power R minus A R cap upon R square, that is equals to rho upon epsilon naught. Now you can proceed with the as usual process, like how to deal divergence. Okay, so that is equals to E0 e to the power minus r by a divergence of r cap upon r square plus E0 r cap upon r square, and this is gradient of e to the power minus r of a. Okay, so that is equals to rho upon epsilon naught. Yes, so we take a E0 common, so that is equals to e to the power minus r upon a divergence of r cap upon r square, gradient of e to the power minus r of a rho upon epsilon naught. Okay, so we already know that divergence of r cap upon r square is nothing but a conical delta functions. Okay, we already know in our so actually we have discussed I think in lecture number 1 or lecture number 2. Please kindly check. Okay, I think those guys who were following my lectures from lecture number 1 to lecture number 6, so they already know what is the exact form of divergence of r cap upon r square and how to solve the divergence, that kind of divergence, especially divergence of r cap r square, why it is conical delta. Okay, I was discussed in later case. I was discussed in the previous videos. Sorry. Okay, I have already discussed, right? So that is equals to a to the power minus r upon a divergence of r cap upon r square is nothing but, this is the 3-dimension case, so that is equals to delta cube r plus r cap upon r square. So that is equals to, this is equals to dot, that is equals to dot. So when you solve this gradient, that is r cap del r e to the power minus r upon a, that is equals to rho upon epsilon naught. Okay, so that is equals to e naught e to the power minus r upon a delta cube r vectors plus r cap upon r square into r cap, so that is equals to e to the power minus r upon a minus 1 upon a, that is equals to rho upon epsilon naught. So finally E0 equals to e to the power minus r upon a delta cube r vectors, so r cap is equals to 1, so plus 1 upon r square e to the power r by a minus 1 by a equals to rho upon epsilon naught. Okay, understood what I actually calculated, how we calculated this type of problems actually. Okay, so finally we get the charge density. Rho equals to epsilon naught e naught equals to e to the power minus r of a delta cube r vectors minus 1 upon a r square e to the power minus r of a. So this is the actually charge density. Okay, charge density. Now using this charge density expressions to calculate total charge. So now the total charge, in the distributions electrical charge in the distributions is Q equals to rho dB. Okay, this is equals to rho dB. So rho is already rho we have already calculated, right? So Q equals to epsilon naught E naught e to the power minus r upon a delta cube r vectors minus a upon r square e to the power r upon a. So dv is nothing but 4 pi r square dv. Dr. Why here? Actually charge density is only depends on r. That's why. Otherwise you can write dv equals to r square r dr r d theta r sin theta d phi. So that is after that calculations we already get this. Okay, so I think no need to explain how to write dv equals to 4 pi r square dr. Okay, so let us calculate. So 4 pi epsilon naught e naught so that is equals to integrations. We have only r limit 0 to capital R is the radius, so that is equals to e to the power r by a delta cube r vectors dr minus 1 upon a 0 to r e to the power minus r by a dr. I think is there r square is there, right? Yes, and also r square is there. Yeah, definitely. So that is equals to 4 pi epsilon naught e naught. So that part will be 0 because we use the Dirac delta function rules. R equals to 0, so it was equals to 0. Actually it means e to the power 0 into 0 minus 1 upon a 0 to r square e to the power minus r upon a dr. So so this is your so finally we get the result like that. 4 pi epsilon naught e naught minus 1 upon a 0 to r square e to the power minus r by a dr. I hope you definitely solve these integrations. Okay, I hope you definitely solve these integrations, and please solve it by yourself. Okay, please solve it by yourself. It's a very easy task for you. I hope this is a very easy task for you. So I have so I have discussed a beautiful problem here. Okay, let's step forward to the problems number 2. This is another beautiful problems. Okay, this is another beautiful problems. Okay, let's take another problems. Just keep in mind, please solve these integrations. Okay, please solve the integrations. Okay, please solve the integrations. Okay, understood what I say actually. So question number 2. A spherical symmetry symmetric charge distributions spherical symmetric charge distributions is given by rho of r equals to rho 0 1 minus r square upon a square for r less than equals to a and 0 for r greater than equals to a. Okay, so find the electric field. Find the electric field everywhere. Find the electric field everywhere. So it's nice questions. Okay. So again. Okay. By solving this integrations which I have already discussed, okay, we can find the result like 4 pi r square e. Okay, so that is equals to 1 upon 4 pi epsilon naught, and q enclosed is nothing but rho dv. But here already given the value of rho, but rho is exist up to r equals to a and some r equals to a and less than a, right? R equals to a and less than a. Okay, so that is equals to 1 upon epsilon naught r equals to 0 to r. R here is nothing but the radius of Gaussian surface. So Gaussian surface mean radius of this part. Okay, radius of this regions only. So okay, so this is equals to rho naught 1 minus r square upon a square, and dv is nothing but 4 pi r square dr. Okay, so rho upon epsilon naught, 4 pi also is taken out, so 0 to r 1 minus r square upon a square into dr, so that is equals to 4 pi rho naught upon epsilon naught. Okay, so 0 to r r square dr into 0 to r to the power 4 upon f square dr. So let's solve the integrations. It's very easy. So 4 pi rho naught upon epsilon naught, and we get, this is the by solving these integrations, we get actually r cube upon 3 minus r to the power 5 upon 5a square. So we get finally what do we get actually 4 pi rho naught upon epsilon naught into r cube upon 3 r to the power 5 upon a square. Okay, so the final expressions of electric field is equals to rho naught upon epsilon of pi. 4 pi is actually cancel each others, and r square is the left hand side. Okay, so after dividing this r square we get r upon 3 r cube upon 5 square. So this is the final expressions of electric field at r less than a. Okay, now electric field outside the charge distributions. Okay, electric field outside the charge distributions. It means r greater than a, outside the charge distributions. Okay, So you have a sphere already, we have a sphere of radius a, okay, and we are trying to calculate at any outside point yes, at a radius r. Okay, so this is the nothing but a Gaussian surface. Okay, so again we use the integral form of Gauss's law. So that is equals to E dot ds equals to Qn closed upon epsilon naught. Again by solving these integrations, so that is equals to 4 pi r square dr epsilon naught, and Qn closed is nothing but rho dv. But here rho is equals to rho naught 1 minus r square a square, dv equals to 4 pi r square dr, but here r is equals to 0 to a, because this charge density is exist only r equals to small a, okay, r equals to small a. So that's why here we take limit r equals to 0 to a, because beyond this r equals to a, there is no charge distributions. Okay, there is no charge distributions. You just remember. So beyond r equals to a, there has no charge distributions, right? Okay, so 1 upon epsilon naught and 4y is taken out, 4 pi rho naught is taken out, so that is equals to 0 to a r square dr minus 0 to a r to the power 4 upon a square dr. So okay, so that is equals to a cube upon 3 and also a cube upon 5. So finally we get 4 pi rho naught on epsilon naught to a cube upon 15, right? 2a cube upon 15. So electric field magnitudes is equals to rho upon epsilon naught to a cube 115 into 1 upon r square. So that is equals to 2 upon 15 rho upon epsilon naught into a cube upon r square. So that is the electric field are greater than a. So in vector form, 2 upon 15 rho upon epsilon naught a cube upon r square, so that is equals to r greater than a. Okay, so I think you understood what I calculate, how to calculate those problems actually. Okay, next calculate another good problems, right? Another good problem, that is question number 3. Question number 3, a charge distribution distributions gives rise to the electric field E vectors equals to C 1 minus e to the power alpha r r cube upon r square. So find the net charge. Find the net charge content within a radius r equals to 1 by alpha. Okay. Okay, so what is the solutions part? It's a very interesting. So again, given here electric field equals to C 1 minus e to the power alpha r cap upon r square. So find the net charge. Again we okay, so once again we will follow the same approach to find the total charge. Okay, use the differential form of Gauss's law, and from this differential form of Gauss's law we calculate charge density and use that charge density for calculation total charge. Okay, this is our basic stage. We have already followed in the question 1. Okay, so again we follow the same approach here. Okay, so we are going to follow the same approach. Okay, right? So right. Okay, so the differential form of Gauss's law. Gauss's law, this is nothing but divergence of E equals to rho upon epsilon. Here again, you see electric field given in spherical polar coordinate systems, but only radial component. Okay, but only radial component. But keep in mind, when electric field given like that, E vectors is equals to f of r into r cap upon r square. In that manners. So how to solve the how to solve this vector field in divergence? I mean, how to deal with this kind of vector field, divergence of this vector field. It's very important. Okay, so when give you vector field like that, so how to deal with that vector field in divergence? So it's a very very crucial learning part. I think you got my point. Right? Okay, so here you notice the given electric field have the same form. Okay, in the previous questions also, I mean question number 1. Okay, so understood. So that is equals to C 1 minus plus e to the power alpha r cube upon r square, that is equals to rho upon epsilon. So how to solve this? So this is the scalar part and this is the vector part. Okay, so first of all we take scalar part. C 1 minus e to the power plus alpha r, that is equals to divergence of r cap upon r square plus C r cap upon r square dot gradient of scalar plot. Okay, so this is a very important part. So rho upon epsilon naught, right? So we are already know the divergence of that vector quantity is nothing but Dirac delta functions. Okay, so C 1 minus e to the power alpha r delta cube r vectors plus C r cap upon r square dot r cap del r 1 minus e to the power alpha r equals to rho upon epsilon. So C 1 minus e to the power alpha r delta cube r vectors plus C 1 upon r square, okay, that is equals to minus of alpha e to the power alpha r, that is equals to rho upon epsilon naught. So C C 1 minus e to the power alpha r delta cube r vectors minus C alpha upon r square e to the power alpha r rho upon epsilon naught. So rho equals to C epsilon naught 1 minus e to the power alpha r delta cube r vectors minus alpha upon r square e to the power alpha r. So again this is the charge density. Okay, charge density. Okay, this is the charge density. Generally this integration is nothing but 4 pi delta cube r. Okay, you can write here also 4 pi. Right here is a 4 pi. So that is equals to 4 pi delta cube r. Okay, is there any minus? Let's look at the question paper. One thing, got my point. Yeah, there is no minus, right? I think there is a minus. Oh, sorry. In question there is a minus. Okay, minus. Please take a note. This is a minus. So all are minus. Please correct yourself. Minus. So this minus is plus. This is plus. This is plus. This is minus. And this is minus. Okay, this is minus, this is minus. Okay, this is minus. I mean finally we get the total charge density is rho of r C epsilon naught 1 minus e to the power alpha r 4 pi delta cube r plus alpha upon r square e to the power minus alpha r. Okay, so this is the charge density. Now we calculate net charge. So net charge contained within a radius r equals to 1 upon alpha. Okay, so q is equals to nothing but rho dB. So that is equals to r equals to 0 to r C epsilon naught 1 minus e to the power alpha r 4 pi delta cube r minus plus alpha upon r square e to the power alpha r 4 pi r square dr. So okay, so that is equals to 4 pi C epsilon naught 0 to r 1 minus epsilon alpha r square 4 pi delta cube r dr plus 0 to r okay alpha to the power minus alpha r square cancel each other into dr. Okay, so that is equals to that part will be again 0 because due to this Dirac delta functions. So we get finally 4 pi C epsilon naught 0 to r, this is alpha e to the power minus alpha r dr. Alpha e to the power minus alpha r minus alpha 0 to r. Okay, so that is equals to 4 pi C epsilon alpha minus e to the power alpha r minus plus 1 by alpha. So alpha is cancel each others, so 4 pi C epsilon naught 1 minus e to the power alpha r. Okay, so Q at r equals to 1 by alpha is nothing but 4 pi C epsilon naught 1 minus e to the power minus 1. So 4 pi C epsilon naught 1 minus 1 upon e. So this is the exact form of total charge within a radius r equals to alpha. I think you learn how to deal when a electric field is given in your question paper and they asked what is the net charge. Okay, so in this way you definitely follow the step and you get the result in a beautiful way. Okay, understood what is what step actually I followed here, right? So okay, I can give you one homework questions also, that is question number 4. Okay, I can give you one question for homework. So I suggest please solve the homework part and solve my number. I already mentioned each and every videos. Please send my WhatsApp number the solutions of these questions. Otherwise I don't know you guys are solved or no, so you guys are able to solve these problems or not. Okay, so it's your own responsibility to solve it by yourself and send me my WhatsApp. So it's, like, sir, this is the solutions of that questions of videos lecture number 6 or lecture number 7. I every in each and every lectures, at the end of the lectures I will I always give you a small homework for your for your self understanding, to build your self understandings actually. So try to solve it, okay. So this is the homework questions. That is question number 5 or 4. That is question number 4 actually. The total charge in a sphere of radius r about the center of a spherical cloud of radius a, each q r square upon a square into e to the power minus r by a minus e to the power minus 2r by a. This is the total charge. Find out the electric field find out the corresponding electric field. Okay, this is the homework part. Okay, I can give you another questions also. Question number 5. The electric field in a certain regions is given by E vectors equals to a x I cap y j cap x square plus y square. It means the electric field given is Cartesian coordinate systems, where a is a constant. Find the total charge. Within a sphere of radius r with center at the origin. Okay, with center at the origin. Okay, so this is your another homework. So try to solve these two questions. Okay, keep in mind one thing, in my Facebook page, right, Q Physics Academy, I definitely post the solutions of these two questions. Okay, so those who were not following my Facebook page, please follow the Facebook page. I upload every homework question solutions in my Facebook page. Okay, actually in the lectures video I am not dealing the solutions. Okay, I'm not dealing the solutions, so don't expect sir will solve the solutions in the videos when sir upload the videos in, like, when upload the next video. No, this is our not, I'm not solving here. Okay, I'm not solving here. I definitely post the solutions in my Facebook page. So this is your responsibility. After solving this, after solve the questions, please send me, or if you feel shy, just check it from my Facebook page. Okay, so I think you have learned here how to calculate the total charge from the given electric field, and there's for the spherical charge distributions. This is the most famous, those are the most famous problems asked in examinations, and also this is a very conceptual questions. Those are very conceptual questions. Okay, so you have to learn it. I think this two homework is also useful to your self concept building purpose. So please try to solve those homework problems and send me. Otherwise you can check out from my Facebook page. Okay, thank you for watching this video, and keep learning.